So now let us see some applications of corollary 1. So say you have this sets u, v, u intersection v, they're all open, pathwise connected, and x is covered with u and v. X is equal to u union v. There is a common base point. Now if u intersection v is simply connected, that is its fundamental group is trivial and it is non-empty, then pi 1 of x is pi 1 u star pi 1 v. So you have this diagram here, the functor pi 1 takes you here. Notice that you have a trivial group here. So let us see its application. So we want to find the fundamental group of S1 wedge with S1. So S1 wedge with S1 looks something like this. So you have a common base point right here. So we have to construct sets u and v and their intersection. So you take set u like this, one point is missing here. Take set v like this, one point is missing here. This is u intersection v. So first notice u intersection v, all these four whiskers will deformation retract to the point. So this will be equal to point. So its fundamental group is trivial. Now coming to pi 1 of u. So these two whiskers will retract to this point. So this will be equal to S1, some point here. Similarly here, these two whiskers will retract to this point. So this will also be S1. So pi 1 of u would be integers because this is S1. For v also it will be integers. Use this result. So you have pi 1 of S1 wedge with S1. This will give you this free product. And this you can extend to any number of wedge products. So if you have another wedge, if you have something like this, this will become this. And so on. Now we discuss another example. So in this example, this pi 1 u intersection v is not trivial. So we just apply functor pi 1 here. So this is for the sphere. This is sphere is union of two sets u and v, where u is nothing but sphere minus the north pole and v is also sphere minus the south pole. So this is very easy to picture. So you take S2 and you take this point out. So if you take a point out, this will deformation retract to a point. So its fundamental group is trivial. So for this is say u Sn minus north pole. So fundamental group here is trivial. Similarly for v, if you take the south pole out, this will again deformation retract to a point. So this is also trivial. So you just have two trivial groups here. So that would mean that this pi 1 of Sn, this is equal to a trivial group. Then you star it with the trivial group, and there is some amalgamation here because we haven't talked about pi 1 u intersection v. So pi 1 u intersection v is obviously the equator. So in this case it will be Sn minus 1, and we are not talking about it. But if you amalgamate two trivial groups, what you just get is a trivial group. So this is a proof that Sn is simply connected. You take its fundamental group, you get a trivial group. So we have forgotten the amalgamation here.